Alright, so the last part of 3.2 we covered before spring break talked about finding the zeros of, or the solutions of a function. Alright, and we did that, just kind of looking back through these, you can factor it out, sometimes it's already factored for you, but basically you're trying to find the numbers that when you plug in for x, it gives you 0. Alright, now we saw in a couple of those examples that one number might happen more than once. Alright, and so if a number ends up being a 0 more than once, we call that the multiplicity of a 0. Okay, it's the number of times that a particular number pops up as a 0 or an answer. Alright, and what that means graphically for us, which we're going to graph here in a second, if the multiplicity is odd, it's going to cross through the x-axis wherever that 0 is. Okay, so if here's the x-axis, okay, if you had this number right here, let's call it 2, as one of your answers, and that had an odd multiplicity, it's going to cross through the graph right there. Okay? If we had an odd multiplicity. Okay, if it's just 1, it's going to cross just like this, or it might come up from the bottom. If it was like a multiplicity of 3, we might see that in an example, I'm not sure, is going to kind of flatten out a little bit, but still cross through. All right, and then with even multiplicity, it's going to touch the x-axis and turn back around. I call it touch and turn. Okay, so what's going to happen there is that, hey, I'm coming down to hit this particular answer. All right, but if it's an even multiplicity, it's going to touch it and then it's going to turn right back around. Okay, kind of like a parabola. All right, and we'll do more of those graphs later. Okay, but really when you're looking at an example, find the zeros of this function and give the multiplicity of each 0. It's already factored out for you. You just take each parentheses and set it equal to 0. X plus 1 equal to 0. You subtract the 1. And that gives you the x is equal to negative 1 is one of my zeros. All right. Then you look and see that, hey, is there an exponent for this parentheses x plus 1? There isn't, so this one has a multiplicity of 1. And since that number 1, the multiplicity is odd, it's going to cross. All right, and then you take the other parentheses, the 2x minus 3. You set it equal to 0. You solve that equation out, add 3, divide by 2. And so x is equal to 1.5 or 3 halves. All right, and that has a multiplicity of, well, you look at the exponent. What's the exponent? 2. So it has a multiplicity of 2. And it's going to touch and turn. All right, if you want to pause, and then I'll put the answers for the checkpoint 7. Just pause the video at this point. All right, here are the answers to that one. All right, you have a negative 1/2 with a multiplicity of 2, because that's what the first parentheses gives you with that exponent. So it's going to touch and turn since that's even. And then you're going to have 5 from the second exponent, or second parentheses. And since the exponent is 3, that's odd, multiplicity of 3, it's going to cross. All right, to graph a polynomial function. Okay, we spent some time before spring break talking about end behavior and finding zeros, and talked about multiplicities of zeros just a second ago. All right, and so this is what you do to use all that information to graph. Okay, number 1, use a leading coefficient test, determine how it's going to look overall. That's the end behavior. You're going to find the x-intercepts. setting equal to 0. That's what we kind of did this lesson as well. Talks about the multiplicity, even and odd multiplicity. If it's greater than 1, it's going to flatten out near there. Find the y-intercept by plugging in 0. We're not really going to talk about symmetry, which you can. And use the fact that the maximum number of, we can do that, but we'll just kind of see what's happening here. Okay? All right, so let's look at this first one. Example 9. All right, so function right here, it is not factored for us, so we're going to need to do that in a second, but we can go ahead and do the first part. The first step is the end behavior. All right, and remember for the end behavior, you look at the highest degree, or the degree of the function. All right, so since the degree is 4, which is even, and the leading coefficient, the number in front of x to the 4th, is 1, which is positive. So even and positive. All right, we know that it's going to even, it's going to go the same way both to the left and to the right. Since it's positive, that means it's going to be up. So we know the graph at the ends is going to look like this. All right, and then the middle stuff we find from finding our zeros. All right, so step 2, find the x-intercepts. So we're going to have to set this equal to 0. All right, so if we set the function equal to 0, all right, and this one will factor. It's going to factor like a quadratic because we have a 4 here and the 2 here. It's going to look like a quadratic factoring. It's just going to have x squared in both places. X squared. X squared. And that's going to be x squared minus 1, x squared minus 1. The negative 1 times the negative 1 gives me positive 1. The negative 1 plus the negative 1 gives me the negative 2. Those in turn will factor into difference of two squares, x plus 1, x minus 1 for the first one, x plus 1, x minus 1 for the second. And so if you kind of rewrite that, you notice you have x plus 1, and how many of those do I have? I got 1, 2 of them, so x plus 1 squared. I've also got x minus 1 twice, so I square that. All right, so from your first parentheses, you get negative 1 is a 0. You look at its exponent, it's a multiplicity of 2, which means it's going to touch and turn. And I'm going to abbreviate t and t. All right, from the other parentheses, you get 1 is one of the zeros. It has a multiplicity of also 2, and it's going to touch and turn because of the even multiplicity. All right, third step, find the y-intercept. And that, to find the y-intercept, all you have to do is plug 0 in. So you have f of 0, which is going to be 0 to the 4th minus 2 times 0 squared plus 1. So it turns out my y-intercept is 1. All right, and then we can use that to graph. We know it's going to cross, we're just going to have zeros at negative 1 and positive 1. So x-intercepts there. We know the y-intercept is also 1. All right, so you place those on your graph. All right, and then basically we're going to draw it using what we know about our end behavior and our zeros and whether they touch and turn or cross. So we know it's going to be coming from the top because of our end behavior. All right, so it's going to be coming down. All right, and then at negative 1, we know it's going to touch and turn. So the first place it interacts with the x-axis is at negative 1. It's going to touch and turn around. All right, and then before it gets to the next intercept, it's got to cross the y-axis, so I know it crosses here. And since I've got to get back down to the x-axis, at some point it's got to turn back around. So I can hit this point here. And then at that 1, we also know it's a even multiplicity, so it's going to touch and turn. So it's going to touch and it's going to turn back up. All right, and since I don't have to touch or it's not going to hit the x-axis anymore because it only hits at the negative 1 and 1, I know I'm just going to keep on going up. And that actually follows our end behavior that we already talked about. All right, that's how it's done. All right, you might want to pause and try this one by yourself before I work it out. All right, in behavior, it's going to be odd, positive. Odd, positive, because I got 3 and then no positive coefficient up front. So odd, positive means it's going to look like this. 2, I set it equal to 0. All right, I can factor out an x squared. So leave me with x minus 3. And so from the x squared, I get 0 as a 0. That has a multiplicity of 2 because of the exponent of 2, which means it's going to touch and turn. And then the parentheses x minus 3 gives me 3 with a multiplicity of 1 because there is no exponent on that parentheses, so it's going to cross. All right, 3 or y-intercept, what do you get when you plug 0 in? Well, that's 0 cubed minus 3 times 0 squared, so that's also going to be 0. All right, so we have these points. We know it crosses the x and y axis at the origin, and it also crosses the x-axis at 3. All right, and so actually now we have enough to graph. Okay, based on my end behavior, I know it's going to start from the bottom. All right. And so the first time it interacts with the x-axis and the y-axis at the same time, it's at 0, which is going to be a multiplicity of 2, touch and turn. So I know I'm going to go, hey, here, hit it at 0, and turn back around. See if I can actually touch it. All right. Now it's got to hit the x-axis again up at 3, so at some point, okay, I'm not really exactly sure, just with our analysis right here, when it's going to turn around. But we know it's got to turn back around and hit the x-axis at 3. It's going to cross there, so it's not going to touch and turn. It's going to cross. And since it doesn't have to hit the x-axis ever again, it's just going to keep on going. And that follows our pattern. All right, and then finally we're going to look at example 10 and checkpoint 10 here. All right, and these are nice because they're already factored for us. Okay, the end behavior is a little bit more we got to look at. It's x, which is squared, and then x to the first, so 2 plus 1, we have a degree of 3. Okay, remember if it's not all the way multiplied out like the previous checkpoint in example 9, you can look at the exponents and add them together, 2 and 1, which is 3. And then our leading coefficient is that negative 2 right there. So we've got odd and negative. That means we're going to be going rising to the left, falling to the right. Step 2, we set each of our parentheses equal to 0. So from the first one we get 1, x minus 1, so we get set equal to 0. That gives me 1. It's got a multiplicity of 2, so it's going to touch and turn. And the second parentheses gives me negative 2, which has a multiplicity of 1, which is odd, so it's going to cross. All right, and then step 3. So 1 and negative 2 we got for the parentheses. Step 3, plug 0 in. So you get negative 2 times 0 minus 1 squared. times 0 plus 2. That's going to give me negative 2 times a negative 1 squared times 2. So negative 2, we square the negative 1, it becomes positive, times another 2, which gives you negative 4. Alright, so we graph those points. We graph the y-intercept of negative 4 and x-intercepts of negative 2 and positive 1. Alright, and then we look at our end behavior. We know it's going to start from the top. Okay, so I'm going to start up here, kind of close to the first x-axis, x-intercept point, a little bit to the left. I know at negative 2 it's going to cross. So I'm going to draw this nicely. So it's going to cross here at negative 2. Alright, it's going to keep on going down. At some point it's going to turn back around. I'm not exactly sure, and I'm not really concerned with it at this point in college algebra. Alright, but it's going to come back up, and it's got to cross through the y-axis at negative 4. And then the next thing we got to do is we got to hit 1, and we got to touch and turn. So, stay there. Alright, so it's a cross through the y-axis. Go up at positive 1, and it's going to touch and turn back around. Alright, and we're not exactly sure where it turns right around here with what we know, but as far as college algebra is concerned, this is all we have to do. Alright, so you might want to pause. I'm going to work through, before you work through checkpoint 10, you might want to try it yourself. Degree of 3, leading coefficient of 2, so it's going to look like this. Got negative 2 from the first parentheses. It's got a multiplicity of 2, which means it's going to touch and turn. I've got 3 with the multiplicity of 1, so it's going to cross. And then when I plug 0 in, I think this one might be way off the charts. 2 times 0 plus 2 squared times 0 minus 3. Yeah, it's going to end up giving us a negative 24. Alright, so we really can't. It's going to be way down here off the graph. But I do know negative 2 and 3. I know it's coming from the bottom because of my leading coefficient test. At negative 2, it's going to touch and turn. Alright, and then way down here somewhere, okay, way off the graph, so I'm kind of being a little bit generous down here. It's going to turn back around. Just realize that's actually going to be way down off the graph. Try not to. And then it's got to hit the x-axis here up at 3. All right, and that's the rest of 3.2.